Alright, so I think this is recording. We're taking a look at skill packet 5 problems, which is problems involving exponential functions and log functions. And on these problems that I'm doing in this video, we're focusing on logarithmic functions and specifically logarithmic expressions, where we want to use properties of logarithms. And you'll be given a reference sheet that has these formulas on it. But if you don't know these formulas well enough, if you have a quiz or a test and you're staring at the formulas, you're not going to have enough time to finish the problem. So you should really just use the reference sheet kind of just as a crutch, just for confidence builder. You really need to know these formulas and stuff by heart. All right, so let's take a look here. The directions are saying to use those properties to simplify this to a single logarithm, and then from our single logarithm to use that final property, that change of base formula, to get a decimal approximation on the calculator. So we have a property that says that when you're adding two logarithms together, you can write it as a single logarithm if you multiply these arguments together. 5 times 9 is 45. So now these two terms can be replaced with log base 4 of 45. So then we're subtracting log base 4 of 10. Now these properties only hold true if all of these terms have the same base. Notice that all of these were base b in our formula here. All right. Subtraction of two logs can be written as a single logarithm if you write it as a fraction, and the numerator is 45 and the denominator is 10. Alright, so both of those are divisible by 5, so I can reduce that fraction to 9 over 2. If I go to a calculator, the calculator can tell me a decimal approximation. If I take the log of 9 halves and I divide it by the log of 4, 1.085. Alright, so that's what it wanted. To write it as a single logarithm, this is an exact value, and then to approximate it to 3 decimals. The next problem, how are we going to simplify this? The bases are the same, so I can apply my properties. I have the addition of 2 logs. I can write that as a single logarithm. If I multiply these arguments, in 2 times 18, I think is 36. Now, remember that they expect me to simplify when possible. I can use the change of base formula, or I can just recognize that 6 squared is 36, and that this logarithm equals 2. If you don't recognize that, you can use your change of base formula. And now, here, let's do it on the calculator, because they wanted me to simplify it, to write it as a single logarithm. When you go to the calculator, you take the log of 36, close the parenthesis, divided by the log of 6, and I claim that this is going to be the number 2, and there it is. Alright. So this, let's do it in a few steps. Let's not do too much at once. This coefficient of 3 comes up as a exponent. So I have log base 2 of 6 to the 3rd power plus log base 2 of 3. I'm going to move from left to right as I do these. You can take shortcuts once you get good at these, but I would suggest that you do them a step at a time and go from left to right. So here, 6 to the 3rd, I think, is 216. 6 raised to the 3rd power. And we're going to multiply that by 3. So 648. So these two logs can be written as a single logarithm, log base 2 of 648, minus log base 2 of 18. I can write this as a single logarithm, where I have 648 divided by 18. Now, I don't know. Let's see if that 648 is divisible by 18. It might be 36. So 648 divided by 18 is 36, and 2 to the 5th power is 32. I can't raise 2 to a power to an integer power to get 36, so I'm going to use my calculator to get me a 3 decimal approximation to this. So if I just use the common logarithm, log of 36 divided by log of 2, 5.170. So we used the properties of logarithms, we simplified, we condensed these 3 terms to a single logarithm, and then gave you the decimal approximation for it. Alright, let's do the same thing here. They've grouped this together for me, so yes, I'll do it from left to right, but I'll start with my order of operations. I'll start with inside the parentheses first. So I'm going to leave outside the parentheses alone for just a second. And this is a subtraction, so I can write this difference of 2 logs as a single log, where 2 is in the numerator and 3 is in the denominator, and I can't reduce that fraction. Well, before I try to work with this subtraction, this 1/2 by the power rule gets pulled up as an exponent, so I have log base 7 of 13 raised to the 1/2 power minus log base 7 of this 2/3. This is the difference of 2 logarithms. I can write that as a single logarithm, where I have log base 7. The numerator, I can write 13 to the 1/2 power. I can leave it like that, or I can write it as the square root of 13. I'm subtracting, and I'll divide that by 2/3. Well, most likely they don't want me to leave this as a complex fraction. Well, I don't want you to leave it as a complex fraction. So recognize that to divide by 2/3 is the same as to multiply by the reciprocal. So let's do it over here in case that was too fast. We have the square root of 13. This division bar can be written like this, and when you divide, you can change it to multiplication if you take the reciprocal of the divisor. And if you multiply straight across, you get 3 radical 13 over 2, which is what I have down here. So now they want me to get a decimal approximation for that. So using the change of base formula, we have the log of this very, very ugly fraction, 3 times the square root of 13 divided by 2. That's being divided by the log of 7. 0.867 is what I'm getting to 3 decimals. Alright, so hey, I hope that helps, and I'll talk to you later.